Hello, everyone. Good afternoon. Welcome to the PLT afternoon class. Okay, sorry. Welcome to the afternoon class. Database design and programming with SQL. Yeah, but before we start, I would like to know what did you have for lunch for all my Kenyan people? For all my people in SA, what are you having for lunch currently? For all my people in Nigeria, what are you preparing for lunch? What are you planning to have for lunch? I want to know. Yeah, just tell me in the chats. Okay. Yeah, I'm going to read the chats now. Okay, I see people had Githeri, avocado, nothing. Don't worry. We are together in that, brother. Noodles. Oh, okay. Yeah. All right. All right. All right. All right. Yeah. Thank you so much for all the suggestion. Okay. See, I'm Zablon, a DevOps engineer and also a trainer at PLP, specializing in database design. I'm not alone. We also have our resident data engineer and also the module lead for the database, Mr. Gerard Machechenze. I want to allow him to say hi so that we can start. Gerard, if you're there, kindly unmute and say hi.
Hi, Zablon, and hi to our database community. We hope that you are all well, okay, and I'm much excited to learn and fingle around with the queries, as we call them. So stay tuned. We love you so much. Thank you for the feedback. We've received it for those that were in the town hall. We do try our best to ensure that we capture all the issues that we have. So thank you so much. Stay tuned. Let us have fun. We've got instructor Zablon on the line. Let's go. Over to you.
Amazing. Allow me to share my slides. Okay, before I share my slides, I want to share screen. Yeah, so we can do a recap of week 4 and then we can start today's content or today's topic. So I'll open the assignment in new tab. So this is the assignment, right? Believe everyone has access to the LMS. This is where you get the week 4 assignment. And then once you click, you right click and then open a new tab, you'll be required to accept this assignment. So once you accept, we'll get an notification on our end that maybe John has accepted this assignment, maybe Peter or Brian or anyone, okay, has accepted this assignment. So once you click accept, you'll be directed to a repo that we've created for you. The repo is private, okay? Yeah, the repo is private. Yeah, the repo is private. So don't worry about that. You cannot change it to be public. The repo is private, right? For security reason. Now, first things first, I said, once you have access to the repo, the first place I want you to do is just scroll down. Don't be afraid. Come and read the title. What is the title? Advanced SQL Queries and Aggregation. Read what your the learning objectives, what you'll need, the submission instruction, the assignment question. These are the questions like question 1, question 2, question 3, and then question 4. Not so many, only 4 questions for 7 days. So even if you take one question a day, you'll be done before the 7 days end, right? Now, we also have what you call the answer to SQL, okay? You're not adding a new file, okay? You're not adding a new file. I believe uh, I told some of you to retake your assignment because you added other extra files. Please don't delete this file. This is the file that we use to uh, reward you marks based on how you do your assignment. Okay, so please don't change this file or do not delete it. Now, once you read and understood, just come to the green button. Where's the green button? It's here. Click and then click the drop down. It's gonna open. Click HTTPS. If you are for SSH, click SSH. HTTPS, copy that. I believe that's the one for most. For the majority. Then the next place I want you to head over is your CMD. How do you access your CMD? Click on your keyboard. There's a Windows logo, right? When you click that, write CMD, then open. There it is. As you can, I believe mine is visible in the end, so I'll zoom in. Now, depending on which version of Windows you're using, the path is gonna be different. If you're using Windows 11, your path is gonna, maybe your desktop is gonna be inside what you call a OneDrive, all right? A one. So you need to start by going to the OneDrive. But if you're using Windows 10 going downwards, you can just head over, write CD desktop like that, okay? But if you're using a Windows 11, you need to go to your OneDrive first and then go to your desktop. Why am I going to the desktop? That's where I have all my projects, okay, and all my assignments for easy of access. But if you have, if you like having your assignments in the documents, you can head over to the documents or the download. So CD again, the folder that I created in week 1, that is, I like having all my assignments under this folder. Git clone, paste that link, press enter. Then watch the magic happen. There is the magic. Now, once that is done, where do you get the name of the folder that you just downloaded from the cloud or GitHub? It's here, week 4, PLP database depth. So CD, like that, week 4, PLP database depth. That's my repo. And then the next thing that I will open is VS Code. So code space dots, like that, open. And there it is. So the file is empty, right? So come back here to the README and read the question now. So write an SQL query to show the total payment amount for each payment date from the payments table. Where do I get this payments table? Do you remember the sample DB that I showed you how to import from week 2? That's the one that we'll be using up to week 7, okay? Because week 8 is a different assignment. Now, the next step is to open my SQL workbench. If you're using the terminal, go head over to the terminal. Then I'll log into my SQL workbench. I'll add my password. There I'm directed, right? Now, here it is, sample, the sales DB. If yours is called the sample, no problem. That is still fine. Now, customers, I have the employees, I have the offices, I have the order details, the order, the payments, and the product lines and the products. So right now, the question is asking us to get what? VS Code, yeah. Write an SQL query to show the total payment amount for each payment date from the payments table. This one is simple. Using the aggregation, come and write. So first things first, I need to tell the server which database do I want to work with. So use sales DB. Like that, go to the next slide. Now start writing. We've learned the command to retrieve everything from a table. Which is that command? Select, right? Payment date, comma. I want to do the sum amount. I can give it an alias as amount from payments group by. The payment date. Go to the next line. Order by. The payments date descending order. Like that. Let me just confirm the question again. Okay, show only top 5 latest payments, all right? So we're not done. Limit 5. Right, let's try to execute. What do we get? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah, good. So we are done with question 1. So copy that. The only thing I want to you to copy is the commands. If you verify the commands are working, highlight them, copy, come back to the VS Code, paste it there. Okay, like that. That is question one. You're done. Let's go to question two. Write an SQL query to find the average credit limit of each customer from customers table. I believe everyone has access to this report. That's why I'm reading fast. Display the customer name, country, average credit limit, group the results by customer name. That. Right. That one is also simple, very simple. So do we have the customers table? I'm done with this one. I can remove it. The customers table is here, right? Now, do we have a column called customer name? Yes. We have a country. Yes. So let's write select customer name, comma, country. And then we want to get the average credit limit. As credits, and then from customers group by customer name and the country. There we have it. So that is question two. We are done. Highlight copy. So I've just highlighted and then Control C. That's also another alternative. Okay. And then come to the next line. There, we are done with question two. Let's go to question three. Write an SQL query to find the total price of products ordered from product details and that. Okay, I'll not finish because I know you have access to that repo. So I'll head over and start writing the what? The commands. So select product code, comma, quantity ordered, and then the sum, price each from order details, group by product code, quantity ordered, like that, semicolon, execute, confirm. There we have it. So that is question three. I believe everyone, we are clear. We are not executing from the VS Code. I believe you're seeing what I'm doing. I'm executing from the workbench. I'm confirming my codes are working from the workbench. And if I'm satisfied, now that's when I copy. And then take them where? Take them here. And then I just Control V or paste. Now finally, question four. Write an SQL query to find the highest payment amount for each week. Check number from payments table. Okay. Right. Now, this one, you start by writing select retrieve the check number, comma, the marks, amount, like that, from payments, group by check number. There we have it. So copy, paste it there. So I'm done with my assignment because it was only 4 questions, right? 1, 2, 3, 4. Now, also you can add comments. Just make sure your comments are not wrong, written wrongly, because some of you have been telling you to repeat your assignment because you're writing the comments like this. This is wrong. It's like this. That's how you write the comments. Now, once you're done, come back to your terminal. So first things first, this is the first thing that you write, git status. So after writing git status, it will tell you which file has been changed or has been modified. So the name of the file is usually here in red, okay? Now, the next step is to git add and then the name of the file, like that. And then press enter. And then you git commit -m. I told you write message with that has context, okay? Week for submission. Then press enter. Your final step is to git push. I want to git push, but you will be required to do what? Press enter. Now, once you've done that, come back to the repo, copy again the link for me. Do you see where you're copying the link from? The ones who have been telling you you have a wrong link. Do you see where you're copying the link from? This is where you copy the link from. Now, once you've copied the link, kindly come back to your LMS and then finish the assignment. Like that, you paste the link there. And then you click submit. I won't because I think the learner that I'm using the account has already done that. So once you've done that, you unlock a new week from this side, not at the center of the page, from the right side, the edge of the browser. Use this button to unlock a new week. Yeah, I believe now that is clear. Okay, let's introduce today's topic. So today, we're going to learn an amazing concept in database. So what you're going to learn at the core of this lesson, you learn how to do the following. Number one, you're going to learn how to use different types of joins. You have the inner join, the left join, the right join, and the full outer join to retrieve data from a multiple related table, okay? Yeah, and number two, you're also going to understand the concept of relationship in SQL. So we have the one-to-one, the one-to-many, and the many-to-many, and how they present and how they are represented and managed. Okay. The next thing is you're also going to gain hands-on experience in creating and managing the relationship between tables in a sample database. All right, let's start. Okay, I'm about to drop some trigger words. Sorry, guys. Um, Relationship in SQL. I know when you say relationship, people yeah, yeah, because relationship has shown us dust, most of us, okay? Me, I'm speaking for myself. Now, I don't know about you. I know some of you are good, but relationship for Nairobi guys, Gerald, in your place, is the relationship showing you dust as well? Gerald, are you there? Okay, I think Gerald has left. No problem. So we have different kinds of relationship in SQL. We have the one-to-one, one-to-many, and the many-to-many. All right. So let's start with the what exactly is relationship in algebra. So when you hear the term relationship, it means the relationship between database table in where one of them has a foreign key that references the primary key of another table. Okay. Now, the different types of relationship is the one-to-one, the one-to-many, and the many-to-many. Let's start with the one-to-one. Okay. Now, with the one-to-one, if you're in a relationship and then you get a girlfriend, okay, you do a wedding, you become, I usually hear the pastor saying, you become one or united, right? Now, in SQL world, we have what you call the one-to-one relationship. Now, with one-to-one relationship is where a table, okay, not a table, sorry, a column in one table can be referenced only one time in another table. Okay, I wanna leave here and go to draw IO. So please, if you're writing, just sketch whatever I'll sketch, okay? Now, I wanna leave there, I've left. So I'm in the draw IO now. So I'll pick a table there. I'll call this table users. And then they'll have the user ID. We'll have what we call their first name and their last name. Also, their age and many other details, right? I'll also have another table. Now, in this table, I'll call it profile. Now, we'll have profile ID. We'll also have what we call an profile image, bio, status. Yeah. Now, let me ask, have you ever wondered like how the LMS is able to differentiate? Like, for example, I have the LMS account of this learner, Muna. So how is the LMS able to differentiate between Muna and, for example, me? Okay. So this is my profile, right? And then this is for Muna. So how does the LMS differentiate between me and her? Yeah, maybe you can just maybe write it in the comments. Oh, Zablon, okay. I can see Jared has gone for lunch. No problem. Yes, maybe write in the comments. You can write in the chats, open the chats. How does the LMS know who is who? User ID, Riley Mulati, thank you so much. Primary ID, using the primary key, using the by name, Bob, not really. Email username, the unique identifier. Winston Owen, nice one. Yes, exactly, by using what you call a unique identifier. Now, going back to our draw IO, how do we show like a one-to-one relationship? So you've already drawn your tables, right? Like how I expect you to draw for me in the group work assignment. So just come hover your mouse around these lines. We call them the cardinalities. Now click on that. That is the one-to-one, right? Now I forgot to add something here. Forgot to add another row. We call it the user ID. Now, that is what we call what? The one-to-one. Please, I know you can't draw right now because you'll not be able to switch between screens. So I will highly kindly request that you just draw a sketch, and then once the class is over, you'll have a chance to try it on your own in the Draw IO. Now, if we to come and create tables based on this, I believe you can see the workbench. Let's create a new database. So I'll write create, use the caps, create database. The name of this database, I'll call it the LMS, right? Add that. And then execute from here. 1, 2, 3. You execute, refresh over here. You see the LMS is here. Now, we want to tell the server which database we want to work with. Is the LMS. Now, come here to the next line. Start creating the tables. Now, create table. Okay. Users. Open that. Go to the next line. I'll create an ID. User ID. And then I'll have my data type to be integers. I also want to use this as the unique identifier. So I'll pass a constraint called a primary key. Another thing I want to do is I want to have what you call unique integers. So I want the server to auto-populate the integers for me automatically without me having to remember which was the last one. How do I update now? Just add a what you call a constraint and then right there, auto increment, comma, go to the next line. We'll check in again, first name. This, of course, going to be a variant char. Like that. Age, it's an integer, of course. I'll just have it like that, close it. Now, go to the next line, create the other table. So, profile table. Please write down, okay? Write down the way I'm writing. So, not in your books, the way I'm creating my tables. So, write in your books, create table users, user ID, like that. Now, create table, profile. I'll have your profile ID. And then I'll have these as the integers, primary key. Also, I want the server to take care of the IDs for me for now. Auto increment. So we have the image. The variant char. I'll tell you why, because I'll pass in a link using an image that is stored somewhere else. Okay. The other thing is the bio, which can be a text. What other thing had I written? Okay, we can just leave it at that. Okay, I forgot to add the user ID. So this is gonna be an integer. And then I'm gonna create a one-to-one relationship. So I'll say here foreign key, user ID, preferences. The name of the table at the top is users. Open a bracket, specify this column. Close up, paste it there, or you can write it as well. And then once you're done, so that's how it will look like. Let me zoom out. Is it visible in the end? There, okay, there. So please write if you're writing. That's how you create the tables. And then that's how you signify the one-to-one relationship. So we have our users, and then these are the columns. So we have the first name, the age, and then when it comes to the profile, it has a lot of details. So you can pass in the profile image, you can pass in the bio. Okay, so the bio is this one. Here, where you have the bio. Okay, yes, here. She written as, okay, here. You're about, that's where you write it, the bio. Now, believe you've written this. If you're writing down, please. I don't know if you'll be able to execute at the workbench with the same pace. Okay, user stable. Now, I want to execute this at once. So how do I execute? 1, 2, 3. So once I execute, we get a green check. Is there an issue? No. So we can refresh here and then come here to the table. So we're going to see the profile table and the users table. And there we have it. That is all about the one-to-one or the one-to-one. Okay, I know you'll be asking for this code. I don't know if I'm able to share. Let me see. There, I've shared the code. Believe it's visible. All right, cool. Yeah, I've shared the code. Now we can just copy the code. Yeah, believe this is the most easiest way. So just copy the code and then save it somewhere. So let's go to the next concept, the one-to-many, or we can even touch the many-to-many and then come back to one-to-many. All right. So that's how you can create the one-to-one. This is where a column references another column in another table. So the profile and then the user profile. So let's go to the next page, the one-to-many. Now, this is the most simplest one. All right, this is the most used type of relationship, not the most simplest one, but the most used type of relationship in SQL. So this is where one or more columns can be referenced in another table. So each record in table A can be associated with multiple records in table B. But each record in table B is associated with only one record in table A. What this means is that multiple columns in table A can be associated with multiple columns in table B, but only one column in table B can be, yes, associated with column in table A. Now, if I was to draw, please allow me to go to the draw IO. Now take your pen also, let's sketch. Okay, before I even start sketching, let's go to this site and explain the concept of one-to-many. So for example, this is the categories, right? So if I click, maybe I want a phone, you can see all the type of phones are under the phone category, right? If I want the TVs, I can see the type of TVs that we have here. If I want something else from a different category, I can just click computing and then I'll see all the computers under that category. So this kind of relationship, we call it the one-to-many. Now, how do we draw it? To draw it, first of all, let's create a table called category, and then product. Now, we can create product ID, the name, the price. The other thing, let's just leave it at that because of time. I'll delete this and also this, and then I'll remove this because I'll use something different. And then in the categories, I'll have the category ID and then the name only. All right, so how do we show like one-to-many? So the one-to-many, all right, so meaning when you create products, all the products will fall under a certain category. Okay, so if you have, let's say, maybe toys, and you've created multiple toys, could be a toy car, toy airplane, uh, those toys will fall under the toys category. If you're creating food products, it will fall under the food category. So how do you show like the one to? There we have it. So that's how you can show the one to make, the one to many. Now, believe you've been going through the ERD that I've been showing you in the PLP database. Not here, but like allow me just to digress a little bit. Let's go to this one. For example, if you try to see the ERD, you can see we have the one to many. Okay. Now, if I were to draw the category and the product, I'll just come here and then create new table. Since we have the database, so I don't need to create a database again. Say this one is the category table. Now create table category or categories, open a bracket, go to the next line, and then write this. ID is gonna be an integer. It's gonna be a primary key. Also passing another constraint, auto increment. Oh, by the way, you don't need to depend only on the ID's integer type. You also have another type of integer called the unique identifier, the UUID. Let me just try to see if I can get it. So with the UUID is where it generates for you like these random characters. Okay, believe there are some that will be of 32 digits, there are some will be 64. It just depends with you. So I also think in MySQL we have it. Let me see if I can get it. MySQL. And also when combining it with, let's say, maybe Python or trying to create a project like a full stack project, you'll be required to use UUID, not like the bare IDs, because the bare ID a hacker can easily hack them because he'll just know the sequence. The sequence goes as 1, 2, 3, 4, 5, 6. So they usually try maybe to hit maybe anything that falls under ID 30, and then they'll be able to get. But if you use like you unique identifiers, okay, you call them unique identifiers, it will be hard for them to attack. So you can always try something new. Don't just stick with the IDs, the bare IDs, right? Now let's go to the next one. Now, name, the variant char 20. That one is done. Hi, let's go with the product table. Create a new table, primary key. Create table. Product. Please write down. Okay, let me just finish and then I'll paste it in the charts and then you copy. Product ID, it's integer. And the other thing is what? Primary key. I also want the server to create for me unique integer. So I'll just write here, auto increment, comma, go to the next line, product, product name, varchar 100. Depends with you. You can change it. You can even write other constraints like not null. So you can always play with these constraints. Not null, like that. Go to the next one, amount. The amount, you can write here the amount to be a decimal. So it will take in 10 values, and then I want it to have 2 decimal precision. Also, I'll pass in another constraint called the check. So with the check, it just checks it checks that column to not have any value. Okay, if it has a value above 0. So if you try to maybe write a product with a value of -1, it will throw an error. Okay. The other one, you can always add like things like timestamp and so on. So category ID gonna be an integer. So we create a foreign key. Open a bracket here. Category ID. And then references. So you see, all the unique keywords, I'm writing them in uppercase. The same way I expect you to write them in uppercase. If you send me in small, I'll return you and tell you to retake your assignment. References, the category, open a bracket and right here, category. Oh, sorry, the ID. I'm done, semicolon. So if I execute, I'll have these 2 tables. Okay, we have an error because I wrote the name wrongly. Okay, I'll just come and copy. Don't feel like typing. Now, since this one has been already created, I don't need the server to execute it again. That's why I've commented it. I'll just execute, and there we have it now. So if I refresh, we have the categories and the products. There we have it. So let me copy the code for you. So here's the code there. Now let's go to the final type of relationship, the many-to-many. Now with the many-to-many, okay. So with the many-to-many, this is the most simplest one. Now this is where a column or multiple columns in one table can be referenced by multiple columns in another table. Keep it simple, keep it short. So multiple records in table A can be associated with multiple records in table B and vice versa. Now, the most simplest example I can use, let's say we are creating a database for maybe a university, right? We capture details about the students who attend classes, among other things. The rules are student can enroll in multiple class, maybe 3 to 4 class per semester. Um, Now, to draw something like that, allow me to go to the, this draw.io. I really love this tool. Now we can create. I'll remove this. So I want to create 3 new tables. The first table, I'll call the first table the class. And then I'll take in the name, and then the other one is going to be student. Now, with the student, I'll take in the student ID, name, maybe their age, just the normal information usually give out when you enroll in a campus, right? University. Now, maybe height and among other things. Now, so you might find a class with maybe 20 students, and a student might enroll in multiple classes. For example, a student uh, might be in the chemistry class, maybe the social studies, maybe in the geography class, and you might find another student in the biology, another one in chemistry, another one in physics, and so on. Now, to demonstrate how a many-to-many relationship usually occur, we have to introduce another table that we call adjoining table or a bridging table. Okay. Now, reason being is to ease the work, because if a column stores multiple value, it will be hard to maintain. Now we introduce a new table. We call it a joining table. Now inside this joining table, we call it the class enrollment. All right, so I'll just drag that there. And then here, okay, I'll have the ID. I'll have here the class ID and also the student ID. And then I'll just delete this. I'll come and pick this tool to show like that. I'll pick it again. There, and then this other one there. Now, that's what you call what? A many-to-many relationship. Now, if I was to draw it, I'll come back here to the workbench and then create a table. Okay, create table. Now the table should be what? Class. Okay, create table class, open a bracket, ID, it's an integer. It's also a primary key. Go to the next line. You can add the IDs, the name, and also the variant char of 40, comma, close it at that, create the new table, create the other table. Then create table student, open that, go to the next line and say student ID. Okay, and then part, oh, sorry. Yeah, by the way, you can use also variant char if you want to have alphanumeric. Integer, the primary key, comma, their name, I'll just close it at that, and then create then now the joining table or the bridging table. Okay, so create class, create table, class enrollment. Go to the next line, and then right here, ID is an integer, primary key. Go to the next line, create the class ID, an integer. Go to the next one, student ID. Also an integer, and then you come here and write foreign key class ID, parentheses, class ID, like that, comma, create another one, change here to be student ID, and then here it will be student table, and then student ID over here, like that. So we already have it, so we can just execute. So we are good. Let me just confirm. Yeah, execute. Missing column. Wow, I'm typing fast. No problem. I'll just comment this Supposed to be student. There. Mm, okay, we have it now. Yeah. So let me share it with you. Okay, I'll copy everything. So there. And that's it about the relationship, the various kind of relationship we have in SQL. So before I touch on the next concept, I want to share something with you guys. So yeah, believe this is visible for everyone. So I want you guys to, okay, let me share the link. Where can I get the link? So these are the kind of the question you might get in an interview. And I want to see like your thought process in this one. So if you accept the, if you can see the link that I've shared, kindly just head over to that place. I can see, yeah, we are joining there. Now, please, when you go down, you'll get a dummy data. Okay, so just copy the dummy data, not everything, please, not everything, just the dummy data. Come to your SQL workbench, new working area, paste it there. That is the dummy data, right? So the dummy data does not have a lot of things. Now, I want someone to tell us if you're in an interview, okay? You're being interviewed, maybe for a database administrator role, backend engineer role, or uh, a system administrator role. Now, you're asked this, you want to modify values for some or all rows in a table. For example, you might want to increase the salaries of everyone in the IT department by 10%. Now, if you're confident you can solve this kindly, just come here down. I believe you're allowed to edit. Okay, I don't know if you're allowed to edit, but if you're confident you can be able to solve this, just put your answers in the charts. I'll tell you who's correct, and then I'll know what to give you. Go on. So let's take like 5 minutes. So I'll set the timer for 5 minutes. So right now it's 3:07. By 3:12, we are done. Because even in the interview, you'll be given a lot of minutes to solve this. So you'll be given at least maybe 2 minutes. You think it in your head, and then you tell them the answer. So let's go. Meanwhile, no, we are not in the LMS. We are here. Yes, I'm aware the LMS is down, but the dev team are currently working to resolve the issue. So meanwhile, I wanted to see your thought process in this one. Can you tackle this question? So yeah, I'll share this the Canvas slides later. Anyone who's willing to give it a try? Okay, I see Winston. Winston has shared an answer. All right. Okay. Thank you. Nice try. Felix Atoma, where the department name is the IT. Okay. There's one part where everyone is missing. I can see someone has even used a join. Wow. Wait, you guys are advanced. Hey. Um, update. Let me get the Lillian. Let me get it. Was it Lillian? Or Lindiwe? Okay, update staff, set salary. Yeah, nice try. Repeat the question. We are trying to solve this interview question for those who are late. Hey, Kipkiri Lanat. Yes, Up to a certain point, you guys are correct. Hey, Ronald, you almost got it. Nice try, Bobby. Nice try, Alex. Okay, so if I was to give you guys like a gift, seems like no one would have gotten it. Yes, yes, Longoli, we are using update, but now what are we trying to update? All right, I've already given you the dummy data, right? So here's the data. Now, once you execute, let me just make sure I don't have that database. So if you execute, you'll have what? This database called the Amazon, right? So I've executed, we have the Amazon database. And then inside it has two tables. We have the department, there it is. We have the IT, we have the marketing team, the HR, the finance, right? We also have the staff. Now, when it comes to the staff, we have John, okay, the first name, the department ID, and the salary. Now you've been told to increase the salary of all those who are in the IT department. So how do you get the people who are in the IT department? Come back to the department. Which ID is the IT department? It's ID 1, right? And come back here. Who are the people in the IT? We have Brian, James, Brenda. Now, if I was to update now, I'm done with this. Let me just clear. So I'll do what? I'll write use Amazon. That's the name of the company, path. And then update using the DML commands. The name of the table, staff, okay. Set, we are setting what? Set salary equals to salary multiply by 1.10. Go to the next line because we're increasing the salary by 10%. All right. Now, the next step is where where department ID equals to 1, semicolon. Initially, so please take note of Brian's salary is 120,000. Audrey salary is, okay, Audrey is not in the IT. Brenda is 110 and James 140. So if I execute this and then try to retrieve everything, from staff, we end up getting the entire data. So we have Brian, who is here, 132. Initially, it was 120 here. So it has increased by 10%, 132. James, 154. And Brenda, 121 from 110. So have you seen like how to approach any question that you're given in an interview? This was a very good interview question that I saw somewhere and I said, let me try my student. I have faith in my students. So yeah, I know. So if you try at least writing for me up to the salary times 1.10, and then the where, the department ID, and then you started adding a lot of things there, that's where you are going wrong. I believe that is clear, right? So how is the table associated with the department and the employee using the what? The one to main. Okay, so do you see how these things build upon each other? Okay, now that aside, we are done with the interview part. Just stick around. I have something else. Let me just tell you, I have something else to do with an API. So if you want to learn it, just make sure you stick around. And if you see your friend is not here, just tell them they have missed an important concept. Okay. Also, if you want them not to miss the next concept, tell them to join. Oh, yeah, let's go to the next concept. We have what you call the join. So with the join, now in relational database, we usually say it consists of multiple related tables linked together using a common column, which is known as a foreign key. Because of this, the data in each table is incomplete from a business perspective. Okay. For example, do you remember the week 2 sample database, right? Believe we all have it. Now, if you don't have it, just go to LMS and the week 2 lesson recording, you'll find it there. Then there's also a video on how to import it. Now, if we open the sales DB, you see it has a lot of tables, the customer, the employees, the offices, the order details, the orders, payments, product lines, and that. Let's say maybe you have been told you're working in this company, they've told you we want to see the data from the orders and the order details. So you have to retrieve that for them, and you also have to retrieve the orders for them, right? Two of them differently. But that takes a lot of time, right? Now, what if there was a way to get like complete order information from both tables? That is where now the joins come to play. Now, what is a join? A join, we say a join is a method of linking data between one or more tables based on the values of the common column. Okay. Now, MySQL supports the following types of joins. We have the inner join, the right join, the left join, and the full outer join. All right. Now, let's start with the inner join, the most simplest one. So the inner join, clause joins two tables based on a condition which is known as a join predicate. The inner join clause compares each row from the first table with every row from the second table. Okay. Now, okay, why is my cursor not dragging? Just give me a minute, guys. So for example, going by the sales sample DB, we want maybe we want to get the product code and product name from the products table, and also the text description of product lines from the product table, right? So everything is here. We have the product lines and also have the products table, right? So let's see how we can use the inner join to fetch data from the two table and then provide it as one. Using what? Using the inner join. So I'll remove that. Okay, don't worry about the code. I'll paste it for you once I'm done writing. So use, why do we write use? Tell the server which database we want to work with currently, sales DB. Now, the next step is to, because we want to test the inner join. So select the product code, comma, and also maybe the product name and maybe the text description according to our said before. Maybe these are the columns that I want, since these two columns are in one table and this one is in a different table. Now I'll say from products, table one, and then inner join product lines using what you call a product line. Yeah, using this column. So I'm done. Let me see the code. Yeah, that is. So select product code, product name, text description from products table, and then inner join the product lines using the product line column. The reason why I'm writing using is because all of the table have the same column. Now, if the two table have the same column, name, product line, and in that column, they have the same type of data. So you can see here is string type of data. Now, if I try to execute, what do I get? I get the product code, the product name, and the text description. So these are from table one, and this one is from the second table. So you can see you can use the joins to display data from two tables all at once. So if you want to try this, because I assume you already have the sample DB. So maybe test this. There I've pasted the code that I've written, so you can try it on your end. There. Now, okay, so that's how you can use the inner join to select data from two tables all at once, and then present it to maybe your boss, your supervisor, like that, using the inner join. So remember we said the inner join does what? Uses what you call the join predicate. Right, that is it about the inner join. And now we have what you call a Venn diagram. So the Venn diagram looks like this. It's like how your friends call you to take for a selfie. You come all of you together and then take the selfie. Now, there's another type of join that I want to talk about. We call it the left join. So the left join, the left join selects data starting from the left table. For each row in the left table, the left join compares with every row in the right table. Okay. If the values in the two rows satisfy the join condition, the left join clauses creates a new row whose column contain columns of the rows in both tables and include this row in the result set. For example, if the values in the two rows are not matched, the left join clause still creates a new row whose column contain columns of the row in the left table and null for columns of the rows in the right table. Let's try to write a command to see how the left join is usually written. So with the left join is also another type of join. It's another easy, okay? It's an easy type of join. So to write the left join, let's select that maybe from trying to think, okay, the customers and the orders, right? So each customer can have 0 or more orders whereas each order must belong to one customer. So to write the left join, come here. So we have the customer, we also have the orders, right? Now, left join. So select, by the way, you can try with the different tables and see. You don't have to use the same table that I'm using, but if you want to have the same result as me, you can try with the commands that I'm writing. So select customer name, customer number, order number, from, okay, also the status. I want the status from customers, left join, orders, on, it's orders, on orders, customer, uh, so as you can see, they both have the same column. So instead of writing the is equal, the equal sign customer number, dot customer number like that. So I usually prefer if the two table have the same column, you just need to write using. So instead of all these, you can minimize that and just write using the customer number. So if I execute, and there we have it. So as you can see, we have a nice, yes. Now, for values that do not match, you get what? A null, as you can see here on the right side. Yes, just see how we're getting this null. Because there's no data that's matching on the left table. Yeah, so allow me to copy this code and share it with you. There, I've sent it. So that's the second one is for the left join. So the customers in the left table and orders. So the customer is the left table and orders is the right. The left join clause returns all customer, including the customers who have no order. If a customer has no order, the values in the column of the order number and the status are null, as we were seeing here. Okay. Null. Where is it? Yes. Null. Oh, here, null, null. Because a customer has no order or so there will be no status. That's why we're getting null now. Yes. All right. Now let's learn about a different type of join. We call it the right join. So the right join is also another type of join. Similar to the left join, except that the treatment of left and right table is reversed. The right join starts selecting data from the right table instead of the left table. The right join clause selects all rows from the right table and matches rows in the left table. If a row from the right table does not have a matching rows from the left table, the column of the left table will have a null in the final results. Okay. Now, how do we write a a right join? It's almost similar to the right join, except that you now have to change the word left to right. Um, let's use a different table. So we can select from which table. We have the customers. Yeah, we can use the customers and the employees. So let's do it from the customers and the employees. Um, okay, so select employee number, customer number from customers, right join, employees, on, because it has a different column, on the sales rep, employee number equals to employee number. You can also add an order bar with the employee number. Let's execute, and there we have it. So you can see the right join. That's how uh the left join and the right join. So you can see now it had to fetch everything correct from the table on the right, which is the employees. So everything is correct. Okay. Now, but when you come to the left side, we can see there's null, 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 meaning there's no matching data with the right table. Okay, the table on the right. So let me copy this and send it to you there. So I've sent for the left and the right and the other one. Now let's learn about the other type of join, which is which one now? Okay, my slides are taking time to load. Okay, we've talked about the right join. So the right join, start selecting data from the right table instead of the left table. The right join, cloud selects all rows from the right table and matches the rows in the left table. And then the Venn diagram looks like this. Okay. What's up with this? Yeah, the full outer join. So with the full outer join, returns all records when there is a match, okay, in either left or right. So if I was to write a simple um, full outer join, so this one does not care whether there's a match or there isn't a match. It just return all uh, records, whether it's the left table or the right, okay? So it combines all of it and returns one thing. So we can also use the full outer join. So the full outer join, for example, we can, let's go with which one now? Okay, full outer join. So let's write, now we can maybe thinking of the table to do it. Okay, let's go with the product and the product lines, right? So select the product code, also the product name. Okay, the product. No, I want the product name and the text description. Uh, Another thing, okay, from the table, it's products, a full outer join. Product lines using product line. Okay, I've written this the wrong way. Just description. And there we have it. So it's supposed to be full join, not full outer join. So there it is. We had to fetch what? The product name from the products table, and then the text description is from this other what? These other tables. So we have all these tables are here. Once you import it, you get all this data and then try to play with it. So we have the product lines and we also have the products, which you can use to test. So it's supposed to be full join, not full outer join. There, I've shared it. Now, coming back to the slides. Okay, we've got to the checkpoint question, but before I even touch on the checkpoint question, allow me to digress a little bit. So if you come to our repositories and then go to lab 6, so there's a new lab, so you can just come and clone it. So I'll clone it quickly and show you how it works. Um, and then I'll clone it now. Git clone, paste it, press enter. So the name of the repo is called lab 6, right? Now cd change directory to lab 6. And then once you're in, the next thing is to install all the dependencies. So pip install recursively requirements.txt, press enter. Okay, then once you've done that, there, as you can see, it's installing all the requirements that I need. Come back to your workbench, create a new database. So create database. I'll call it blog. Execute, refresh, make sure it's there. Okay, just even make sure they use plain art. Use blog. Okay, here it is. So let me close these other ones that we are not using. Yes, so I've created a new database. Currently, it doesn't have any table. If I come back to my terminal, we've installed the dependencies. Now, I'll just ignore that error. That one for upgrading pip, but you can also upgrade it. Now, if you come to the post, we are fetching data from an API. Okay. I don't know if you've been taught the API part in your web class and also your Python class. So we have this API that I want you to fetch data, and then this data you store it where? In your database. Okay, locally. We also have the other API from users. where it is. Now the main and the post. So if you come here and try to copy this link and paste it in your browser, you'll see how the API looks like because it's just JSON data. There it is. Okay. If you want the raw data, that's what the raw data looks like. Now we want to make sure this is stored in our database, local database, and then we can play with it. So currently I don't have any tables. Now I'll come back to Visual Studio Code, and the first thing I'll do is pass my password here. That's the only thing you're required to do. Pass in your password to the post also. Okay, come back to the terminal after you've installed all the packages, okay, the dependency list. So now the other thing is to execute. So I'll start with the main, which will create for me a table with list of users. So if I paste, I'll get this message. So once you get this message, data successfully inserted into my SQL database. So come back here, refresh, we get the users table, right? So it's fetching data from the API and then come and installing it in a table. Okay. And now the other one is what? The other one is for post. So after I've passed my password, I'll come back to the terminal and then write post.py, then execute. Data is successfully inserted into my SQL database. Refresh. There it is. So we confirm. There we have dummy data that you can work with. So you can try this with the joins. So I can see we can even try writing a join, select all from the two table, and then maybe where's the users? So we have the users name in the post. You can try to maybe test it with whatever you plan today about the joins. Like select the name and also their blog title. Just give me 1 minute. Let me check something here. Okay. I'll give it an alias. And then for another one is title.p from number one users.u users.u. So that is just an example of an alias. And then oh, today my keyboard is behaving. Inner join the post on user ID is equals to users.id. So where did I make the mistake? Let me just check. The name is there. The email is also there. And also the title. So I wanted to fetch the title. And okay, I'll try it in another way. I'll remove that. I forgot to pass here the P. I think that's why I was getting the error. And there we have it now. So let me just copy this and then send it to you. There. So we can fetch the data from the two table, the post table and the users table. So whatever you see me adding here, we call this the alias. So this is just like a temporary name. So you can see the users with this name and the post that they have created. Yeah, and I believe that's it for today's class. So you have the data, you have everything. Just go to here and then, okay, I know you don't, I don't know if you have this link, but let me share. There. So I've shared the two. Now I believe you're good. Okay, going again, back to our repo. Our Airbnb, it's not yet complete. Yeah, I need guys to review your fellows' work. So I'll need volunteers who can review. If you have some spare time and you want to review what others have done, just come here and then, for example, if I want to review um, Linda's work, you just come here and then go to the files Linda has changed. Step number one, you have to make sure it's airbnb.sql. If it's from a different file, now that you have to tell them now to make sure the file is, all their work is in this file. And then you come here, you check like here right now, if I was the one reviewing Linda's, I'll start from here and then tell Linda, here you have, you've made a mistake here. This is not how the comments are written. And then go to the next work Linda's done. Linda was to create a property underscore category. So this is how she has created. So then just verify with whatever we have in the ERD here, if it's correct. So aside from that, yeah, I just want two volunteers to read for us the checkpoint question and then you guys to answer. And then we can finalize with what? The key takeaways, and then I'll check in the Q&A. I know you have a lot of questions. So, Stace Keriga.
Okay. And
Stace,
I
your
will
mic.
start
Yes, start.
between inner join
So,
and
what's the
a
difference
left
between
join in
inner?
well.
Yeah, what is the difference between
Maybe
an inner join? Stace, let's solve the first one first. What's the difference between an inner join and a left join in SQL? Okay, let me see some of your answers. Please don't Google. Just give me your best shot, okay? Yes. Where the source of the data? No. James Miner, no. Sheila, inner table based on the condition where the left select the data from the left table. Yeah. Go to the next one.
name 3 different types of relationships in SQL.
Yeah. So what are the different types of relationship that we have in SQL? I believe that one is easier. We have the one-to-one, the one-to-many,
Many
and
to
the
many.
many-to-many. Yeah. So maybe you can continue reading this.
Okay. Key takeaways. The inner join clause joins two tables based on a condition which is known as a join predicate. The left join selects data starting from the left table. For each row in the left table, the left join compares with every row in the right table. The right table join starts selecting data from the right table instead of the left table. The full outer join returns a result set table with the matched data of the two tables. Then remaining rows of both left table and then the right table. Oh, yo, that's so tiny. I'm done.
Oh, okay. It's supposed to be full join, not full outer join. Sorry, I did not correct that. Yes, full join. Now, and with that, we've come to the end. So I'm gonna stop the recording so that I can take in your question. For those who are watching the recording, we stop our class here.